Hi, have you ever seen one of these before? Have you? I mean, this is the real size of them. Usually you see them up high, up on the street, but this is the actual size of a traffic light. Do you notice anything different about these different kind of lights? Yeah, I know it's a little different because all three are on at the same time. That's different. But there's something else that's different about this too. You see that this one's made up of little dots, and the other ones are more of a uniform color. So I want to think about a little bit about how we get those different kind of dots and why that is a special kind of light for us. So on here, I've got different materials that are making up each of these so that they give off different lights. But these are all LEDs like we're in the traffic light that we were looking at. So one of the experiments that I want you to do is to find out which one takes more energy to light. So let me explain just a little bit here. On here, there's a little capacitor. That's a thing that stores up energy. So right now, I've got my battery. It's storing up energy in the capacitor. The little lights are running. I'm going to disconnect the battery. When I disconnect the battery, the lights go out. But the lights don't all go out at the same time. So the experiment I'd like you to watch for, tell me which light goes out first. Let's do that one more time. Which light goes out first? Okay, you think it's the blue one? Right, I think the blue one's the one that goes out first. Now let's try a harder one. Which light goes out last? Do that one more time. All right, so which one do you think had the most needed the most energy? Right, the blue one needed the most energy, and the red one needed the least energy. All right, let's do that same experiment a different way. And I'll let you do this one too, but let me show you just at the beginning here. I've got a bunch of little flashlights, so I can differently show each of the different colors. I've got even more colors than I had before. But I've got all these different energy lights, and we're going to use that light to excite a phosphor. That's something that glows in the dark. It takes different colors to do that. So we have this sheet that you can light up, and you're going to be doing this experiment where you can try different colors, and that's not really doing anything. Red doesn't have enough energy to be able to excite this particular phosphor. Let me try another color. Well, no, that's not really doing much either. Let's go try the purple. Oh, look at that. Can you write your initials? Yeah, okay. Try different patterns. So this color has more energy in it than this color does. This is also interesting because this tells us how we can make white light. So we've also got lights like this, and a white light actually has the purple in it, and it also has this phosphor in it. And so white is not really a color. You're seeing both of these at the same time. Here we have two kinds of lights. One of them is an incandescent light, and one of them is an LED light. Now, an incandescent light is one that you have to warm up enough that some of the light comes out in the visible. So that takes a lot of energy to make things hot. Imagine you're running your toaster, and you've got to get your toaster on enough to give out white light. You get a lot of heat as well. So let's look at a couple of things that are different about this. In this, I'm going to flip a switch that turns the lights on and off, and I want to see if you can figure out which one has to warm up to turn on. Heat it up to come on, cool down to go off. Can we tell which one's which? Okay, the one over here is the incandescent one. It goes off a little more slowly, and it turns on a little more slowly, which means we're using energy to heat up, whereas the LED one just comes instantly on, instantly off, because we're just flipping a switch and producing light as it runs through the circuit. So you'll notice that that comes on and off faster. Now, these are actually brake lights from a car, and some car brake lights are incandescent and some car brake lights are LEDs, but the LED ones are safer because when someone steps on the brake and the lights go on, you know sooner that the car in front of you has stopped. So we were talking about how an incandescent bulb had to heat up in order to make light, and an LED just came on instantly. So the traffic light this traffic light has different kinds of bulbs in it. Some of them are incandescent bulbs that have to heat up, and some of them are LEDs. So can I have a volunteer here? Would you mind touching this and tell me which kind it is?
It's hot.
Okay, so which kind do you think that is then? It's the kind that has to heat up. All right, let's try this one.
It's not hot.
It's not as hot. Well, we know this one's LEDs because it's got a clear cover on it, and I can see inside of it. Let's check the answer and see this middle one, if it's really LEDs too. Oh, look, it's made up of lots of little lights. So that one's an LED. That's hardly hot at all. This whole thing is only a 15-watt bulb. This one is a 150-watt bulb. So we're using 10 times more energy, or we're wasting a lot of energy when we use incandescent light bulbs. There's one other thing that's different about LEDs, and that is the way that the electricity turns into light. Turns out that the electricity has to go in at an upper level and come out at a lower level. This is sort of like water running down a stream and going over a waterfall. You get the energy out when the water runs down over the waterfall. You don't get much when the waterfall is running in reverse. So what I have here are two LEDs, and they're hooked up in opposite directions. So I'm going to connect it to a battery, and the red LED lights up because that's the energy going in the right direction. There's another LED that's not lit up because the energy is going in the wrong direction. If I reverse the connection on the battery and hook that up, now the blue LED is hooked up in the right direction. So as I reverse the directions, I can have a red one, or a blue one on, or a red one, or a blue one on, as I go different directions. Now, I'm going to do one more thing, which is hook it up to alternating current. That's where the electricity goes very fast from one direction to another. So as we're looking at this, which ones are on? Is the red one on, or is the blue one on? Oh, they're both on? Well, actually, they're never both on at the same time. The electricity is just reversing directions really fast. So these are never both on at the same time. There's a red one on and then a blue one on, and one goes on, the other goes out. And if we spread them out in space, we can see that they're not on at the same time. So we've seen lots of ways that LEDs are different. They only put out one color. They don't have to warm up to turn on, so they're more energy efficient. They light faster, but they only let electricity run through in one direction. So sometimes people don't like that annoying blink you can see a little bit, but they do save a lot of energy.